Good morning. My name is Matt Stine, and I'm a part of the platform engineering team with Cloud Foundry at Pivotal. And we do lots of very interesting things. One of those is helping our customers to understand what it takes to start to operate in this new world of cloud and continuous delivery, DevOps, and a lot of the other ideas that are sort of floating around in this space right now. And one of them that you may have heard of is this architectural style known as microservices. And so both continuous delivery and microservices are going to be the focus of the talk. And within the context of a couple of things, first of all, Pivotal CF, which is Pivotal's commercial distribution of Cloud Foundry, and Spring Cloud, which is a newly announced set of projects that we first unveiled at Spring 1 this year. And so I'll be talking to you a little bit about how those two products dovetail to make this whole architectural style a lot easier to develop and also to manage as you run it in a production setting. But first of all, I just want to kind of level set things a little bit. And for whatever reason, I'm having trouble advancing my slides. There, we'll go that route. So let's talk about continuous delivery. And basically what I want to do is boil that down to a very basic concept. What are we trying to do? We're trying to shorten the length of time from someone in our business having an idea that we think is actually going to be profitable for us to that idea actually delivering on that profit. And we all know there are many different activities that we have to accomplish between those 2 points in time. And so our idea is just to mash those things together as much as possible. And there's a lot of different ways that we do that. One of the first ways that we do that is we look at all the things that we're doing right now that aren't actually delivering value along that line. And we start to try to eliminate those from our process. But the next thing that we do is we look at what are those activities that we have to engage in, but that could be automated, that we could have computers doing on our behalf so that human beings can focus on sort of the creative, innovative tasks that only we are capable of. And the real question is, okay, that sounds great, but how do I actually do that practically? And there are a lot of different approaches to that. And, you know, one of the places that many of us start is we read a lot of books and we try to figure out how can we get there. But I don't want you to have to go down that road. I just want you to kind of boil this down to really a basic idea that what we're used to doing is we're used to building something and then deploying that something. And all I want to do is flip those tasks around. Instead of building something and then deploying something, I want to deploy something and then build something. Now, that sounds kind of weird at face value, but basically the idea is all of the work that I would normally have to do to get me from I've demoed to the customer and they like the product that we've built to that is actually running in a production environment and real users are using it. All of that work, I want to front load that in my development process. And to do that, I'm going to need to probably build some very basic skeleton of something that I can deploy. And we'll see, Spring Boot makes it incredibly simple to have a very basic deployable web app that actually does a very few interesting things without me actually writing any lines of production code. So we're already enabled by Spring to get to that point very quickly. And so we take that and then we build our deployment pipeline, we build our testing pipeline, and then we start to hang features on that skeleton. And as soon as we hang a feature on that skeleton, we say, can we go to production with it? Well, the answer is yes, because we've done all of the work. So now it just becomes a business choice. Does the business want to actually deploy that thing that we've built to production? And when we do that, we can actually move much more quickly, which is ultimately our goal. And there are businesses doing this. So the one that I like to highlight very often is Warner Music. Warner Music had about 45 years of IT legacy in their business, and that legacy was causing them to suffer 6-month delivery times for very basic services that they wanted to deliver. And so what they decided to do was they took open source Cloud Foundry, they took Spring, they took some data stores like Cassandra, and they built a new, what they called software factory platform that went through and accomplished all of the tasks that I've already talked about. And when they did that, they were actually able to shorten their delivery time from 6 months with a team of 10 to 6 weeks with a team of 10 for roughly equivalent services. And basically what that boiled down to was they were able to keep this iterative wheel spinning, this idea that, we never know when we're actually done. And in fact, if we're building a true product, we never are actually done until we don't need the capability delivered by that product anymore. So what we want to do is enable ourselves to keep getting feedback, keep responding to that feedback, and keep delivering a better product as that wheel spins. And that may be the result of direct customer conversation, or as you see in this outer arrow here, increasingly more this idea of we're capturing events that are happening in the code and streaming those as analytics that we can study and make decisions on and ultimately pour back into the application and have real-time behavioral changes based on what our users are doing. So there are a few other aspects that are sort of forcing us in different directions beyond just this idea of continuous delivery and iteration. There's also this idea of we're wanting to operate at increasingly higher scale. And we figured out several years ago, actually, that vertical scaling was simply too slow and too expensive for us to accomplish our goals. If we have to go requisition new hardware in order to get more processing power so that we can serve the load to the users that we have, we just can't move fast enough. And then as that demand fluctuates, it's not like we can throw away hardware that we bought very easily. It's just not something that works very well. So we move towards virtualization. We move towards obtaining infrastructure through APIs with infrastructure as a service. So using things like AWS and Google Cloud and others. And then now we have this next evolution into deploying things with containers. So I'm sure many of you have heard of projects like Docker that attempt to allow us to acquire multiple instances of applications even more quickly, because instead of spinning up whole machines, we're actually spinning up just containers inside of larger machines. And so we've gone through the spectrum of it takes weeks to days to hours to minutes to now seconds or even sub-seconds to be able to deploy new instances of apps. So that's another thing driving us towards new architectural directions. And then finally, this idea that we can no longer afford to pretend that the user sitting at a workstation using a computer that's tethered to a desk is our primary customer. In the U.S., we measured the traffic on the internet this year, and in January was the first time that we found that now the majority of internet traffic in the United States is coming from mobile devices. So not someone sitting at a computer, but someone on the road, whether it's a phone or a tablet or some other more mobile device, whether it's Apple, Android, Windows Phone, whatever it may be. The vast majority of our users are now interacting with us at more amounts of time from more locations, and quite literally just more people are interacting with our services than ever before. And so we're starting to operate at differing levels of scale and also differing levels of acceptable response time than we have in the past. And our traditional architectures, again, just won't accomplish the goal. So you take kind of all of these factors and you pour them into a funnel, and you have a couple of things come out. On the top, we have this infrastructure change. So I think most of us recognize that we have not usually deployed to physical architecture for a while. We've gone down this virtualization journey, and some of us have gone down the journey of moving that into a public cloud. I think the journey is carrying us all the way now towards leveraging some form of platform as a service. And so that's why I have Pivotal CF here. And the nice thing about Pivotal CF is that I can actually deploy my workloads in my data center and in a public cloud provider in exactly the same way by leveraging that infrastructure. But we also have a very drastic change taking place on the application side. For many years now, we have had this approach of deploying monolithic applications. We create what look like modules, but ultimately we bound those modules up into a single deployable unit. And that becomes the unit of currency as we actually push things into a production environment. And as it turns out, monoliths do not fare very well either in an infrastructure like cloud or in a realm where we're trying to accomplish continuous delivery. And I'll talk about why that is. But ultimately, this is where we're starting to push into this architectural style of microservices. So in order to get the benefits that we have from a platform like Cloud Foundry, we actually have to pay some costs. And I'm not talking about software licensing costs as much as I'm talking about changing the way that I do things. So just as an example, Cloud Foundry optimizes for these things we call 12-factor Linux applications. And I'm not going to go through all of the 12 factors this morning, but if you visit 12factor.net, it's a very quick read. You can read through all of these in about 20 to 30 minutes, more than likely. But just to kind of summarize, we're talking about, for the most part, very small, very focused applications that are stateless, meaning that I can dispose of them very easily. And they start up very quickly, they shut down very cleanly, and they late bind to the configuration information that they can discover from their environment. So there's no configuration baked into a deployable. There's no notion of what services I need to contact baked into the deployable. All of that is actually delivered to the application by the platform it's deployed on. So this is something very different from what we've traditionally built. And then microservices themselves are 12-factor Linux applications, but they also say a little bit more about the team structures that we're going to use, what the purpose of these application services needs to be, and also how we're actually going to segregate not just the running code, but in many cases how we're going to segregate the data in our environment. And all three of those areas, including the 12-factor, the typical enterprise development team is really forced to think about the world a little bit differently. I like to compare this to when we were trying to adopt agile development practices around the turn of the century. So at the time, extreme programming was one of the primary development processes that teams were considering. And when you looked at extreme programming, you had this family of 13 practices. And these 13 practices were expected to be adopted as a whole. But many of us, when we would come and look at these practices, we would selectively adopt the ones that either we understand or that we think are applicable to us, and we would set the other practices aside. And in many cases, when we would do that, we would not get the results that we would expect. We would have failures. And when you would ask the XP practitioners, why am I failing in this environment? Ultimately, the answer would be, well, you didn't adopt all of the practices. And the reason for that is if you look at the practices as they're drawn on the slide here, you see there's this network of relationships between them. And the idea is that each of these practices has strengths and weaknesses. And it's the combination of the practices and the way they support one another in this network that causes them to have a synergistic relationship where the whole is actually vastly greater than the sum of the parts. And as you start to pull practices out of this network, you actually weaken that mesh and make it to where it does not do its job nearly as well. And I think we find this similar relationship when we start talking about platforms like Pivotal CF, Cloud Foundry, and microservices. But neither one of these environments actually implies the other. You can deploy different types of architectures to Cloud Foundry, but as it turns out, microservices are a very natural fit for that deployment environment. At the same time, you don't have to be deploying to an environment like Cloud Foundry to do microservices. But as we'll talk about, when you adopt this architecture, along with all of the good things that you get, there are several major problems that you're going to confront and that you're going to have to find solutions to. And again, as it turns out, a platform like Cloud Foundry is very much geared towards solving exactly that set of problems. So what you end up finding out is that there's sort of symbiotic relationship between Cloud Foundry and the microservices architecture, such that both actually benefit from being used together. So what I want to do now is do a very brief overview of microservices. And I want to start by defining a couple of terms that I use very frequently, and those terms are simple and easy. Now, these seem like words that we use very often, and in many cases, we actually use them interchangeably. So I might call the same thing simple and easy when I really mean essentially the same thing. And Rich Hickey, who is the creator of the Clojure language, he gave a presentation at the Strange Loop conference in 2011 called Simple Made Easy. And in that talk, he wanted to actually tear apart this idea that these are interchangeable words. And he did this by tracing the origin of these words. And he showed that simple actually means one fold or braid, whereas complex means many folds or braids. And the idea is that we should be able to look at the components in an architecture and tell if they're actually decoupled or if they're coupled, or in his words, complected together. And we should be able to look at an architecture and get the same answer objectively as to whether it's a simple architecture or a complex architecture. Whereas easy is very different. Easy has this notion of things that lie near to me. And obviously what lies near to me is not going to be the same as what lies near to you. So when we think about architectures, when we think about software development, we're actually thinking about things that are familiar to us, things that we've done before, the languages that we've used, the frameworks that we've used. If I'm a long-term Spring developer and you're a long-term Ruby developer, we might have a very different definition, for example, of easy. So I'll use both of these words sort of throughout. The monolithic architecture, we don't have to spend a lot of time describing because we're used to it. But basically what we're talking about is usually some rather large monolithic relational database. It doesn't really matter what the exact product is. We're usually talking about, on the other side, some browser-based client. And usually what we've built is some combination of data access objects and some form of service beans, regardless of whether you're using Spring or EJB or something else. And we're talking about server-side MVC with server-side templating of content, probably HTML, probably some smattering of JavaScript. If we're really pushing the envelope, maybe we have some web services API that we can use as an alternative entry point, but in many cases, this is all we're actually delivering. And so when we think about a monolithic architecture like this, right off the bat, I want to describe it as a complex architecture. And I want to describe it as a complex architecture for a couple of reasons. One, we're taking all of these different modular tiers and we're binding them together into a single deployable unit. But not only that, we're taking a whole set of different business concepts from our domain, and we're also joining them together into a single deployable unit. So it's very difficult for us to look at this monolith and say that it has singular focus, because it does not. But these are very easy for us. We're used to this idea of starting a single code base, adding some frameworks, adding a build process, starting to write code and evolving that code over time until we have, again, all of the knowledge about this application system in one place. We all know that over time they become more difficult to work with, but they're very easy to get started with. One of the reasons why these are complex is because the tools that we have for modularity are very difficult to use well. They require an extremely high degree of discipline. So when you think about Java, we basically have classes and packages. And when we use the IDE is very helpful to us, and it will automatically import packages that maybe we shouldn't be using, or it will automatically allow us to access classes or call methods that maybe we shouldn't be using. And so if we don't have a high degree of discipline, or we don't have tooling in place to sort of detect these architectural violations, then we can very quickly create these things that we like to call spaghetti architectures or big balls of mud, whatever term you choose. But the real difficulty here is, even if you were able to keep your modules somewhat untangled, the fact that we're still deploying a single monolithic unit is problematic. And one of the main reasons it's problematic is that it couples not just the deployment together, but also the change cycles. So if we have multiple business units that are asking for functionality and they all go into this monolith, they all have to deploy at the same time. So if one business unit has something that it needs today in order to maintain some competitive advantage, but other code is in flight for other business units that won't be ready for, a week or 2 weeks or longer, we actually have to wait, or we have to take a great deal of risk in order to deploy that. And so what this ultimately turns into is an obstacle to deploying more frequently, which is something we desperately want to be able to do in order to keep that iterative innovation feedback cycle actually moving. But also we have this idea that scaling is inefficient. So we said we have more users, we need to be able to scale. But obviously some areas of our app are going to be hit more heavily than other areas of our application. And if we're deploying a monolith, we don't have the choice in most cases to scale only portions of that application. We actually have to scale all of it or none of it. And as we start to do that, we start to waste resources. Another problem that we run into here is these monolithic architectures, as they grow in size, they can be very intimidating to new developers joining a team. So if you walk in the door as a new developer and you're confronted with a schema with a couple of thousand tables and a couple of thousand Hibernate classes, and then a whole layer of service beans and controllers and screens on top of that, it can be very difficult to be productive, because not only are you learning this architecture, you're learning a new business domain, you're perhaps learning a new set of frameworks, you're learning the people that you're working with, and almost all of those areas have just a large degree of complexity that you have to be familiar with. So it can be very difficult to start getting your job done. So this becomes an obstacle to scaling development up. So one of the ways that we would like to be able to go faster is to do more work in parallel. And we can do more work in parallel if we have more people. But I think most of us are familiar with the experience of throwing more and more people into the same development sandbox and finding out that the more people we add, the less actually gets done. And a lot of that can actually be traced to the monolithic architecture, as we'll see in a moment. And then finally, there's this idea of adopting new technology, which is very, very difficult for us in a monolithic world. And the reason for that is, as we adopt new technologies, we're actually attaching them to these monolithic architectures, meaning that more of the business's functionality is actually accepting the risk of bringing that technology in the door. And this is one of the reasons why we have a hard time and a lot of pushback against adopting technologies that might be appropriate tools to solve a problem that we have in front of us. So when we look at the microservice architecture, it looks very different. And just walking across this slide, in the middle, we see that we have broken the monolith up into a set of different services. So we have 3 different types of services here deployed and a few instances deployed of each. And the 2 on the top have HTTP interfaces. This is probably a REST interface. The service in the bottom in green is an asynchronously driven service. So we have an AMQP message broker like RabbitMQ sitting in the middle of the architecture and divvying up work amongst these services. If you go to the far left of the diagram, you see that we're acknowledging this reality that we have a diversity of clients. If you go to the far right side of the diagram, you see that not only have we broken up the services, but we've also broken up the data. So each of these services is governing its own piece of the business domain's data. And in many cases, it's actually doing that using a specially selected database technology that fits its query and read-write patterns in a very appropriate way. And in between the clients and the microservices themselves, we see this long vertical bar here. This represents what I call an API gateway. And the API gateway's job is to perform tasks like service aggregation, reduce the chattiness between the clients and the microservices, and do things like protocol translation. And the main reason for this is that as we break up our environment into all of these microservices, if all of our clients are, say, for example, our phones need to know about 40, 50, 100, 150 services to get their job done, we're going to have a high degree of latency in displaying screens. We're going to have a lot of network traffic, and ultimately that's going to lead to a poor user experience. And in many cases, actually going to kill the battery on a lot of these devices, which is of critical importance. So we think about microservices, and right out of the gate, I'm going to contrast them by monolith by calling them simple. And they're simple because, as you saw, we're taking all of the different concerns that we have in the architecture, and we're forcing a hard boundary of separation between them. But I call them hard because this is very different from how we've traditionally worked, and there's a lot of challenges that we're going to face that maybe we haven't faced before. And we'll talk about those a little bit later. But we do have a new and better tool for modularity, and that is that we force an API boundary between all of our services so that it's no longer just a method call away to get to some business logic. It's actually a network call away to get to that business logic. And it makes maintaining those architectural boundaries a lot easier because it's a lot more difficult to make those types of calls by mistake. So in a sense, by injecting a little bit of pain into the process, we actually make it easier for us to keep a clean architecture in place. And because we do that, we keep our change cycles decoupled. So those business units that we talked about before, those business units are able to deploy their services when they need them, which means that they can go faster, they can keep that feedback wheel actually spinning. And I can scale more efficiently. So if one business unit service is getting hit very hard by demand and the other services are not, I simply scale up that one business unit service to handle that demand, and I use my resources a lot more efficiently. And then when I join a team like this as a new developer, I'm joining a smaller team with a smaller code base, a smaller data model that I need to learn. And so I have a lot more chance of being productive more quickly because the whole architecture that I face as I walk through the door is a lot less intimidating. And this also enables us to scale development by parallelizing, by adding more people, because instead of throwing everybody into a single sandbox, I can actually just create more sandboxes and divide up into smaller teams. And finally, adopting new technology for developers and architects becomes much less risky because I can adopt that new technology within a single microservice. And I'll usually pick a microservice that is a little less risky, a little less critical to the business, and trial that technology there. And if things work out, great, I can start to roll that across the rest of the microservices. But if things don't work out and I fail, my failure is fairly cheap, and I can actually back that out without affecting a huge amount of the business. So the question that comes up then is how do we actually divide this up? And a very important guiding principle here is what's called Conway's Law. So Melvin Conway wrote down this statement in 1967. He said, an organization that designs a system is going to produce a design whose structure is a copy of the organization's communication structure. And so I challenge you to take a look at your architecture and actually compare it to the way you're actually organized and working, and see if you actually notice this very striking similarity between the way people are organized and the way code gets organized. And if we think about the way that we traditionally organize technical people, we usually do it by specialization. So we take all the DBAs and we put them on a team. We take all the middleware specialists, we put them on a team. We take all the UI specialists and we put them on a team. And not surprisingly, when we group these individuals together into project teams, those individuals recreate those siloed architectures within that monolith that we end up deploying. So creating a microservice type architecture using this kind of organization is going to be very difficult, if not impossible. So the idea is to actually start to organize your teams based on the architecture that you want to produce. And some friends of mine have actually called this the inverse Conway maneuver, this idea of creating an ideal architecture that we want to achieve, and then structuring our teams around business capabilities that will carry us to that architecture. And these business capability teams have all of the roles necessary for delivering not a project that delivers that capability, but a product that delivers that capability. See, project teams are ephemeral. When the project is done, they're usually disbanded, whereas product teams survive throughout the lifetime of a product, and they're responsible for understanding the requirements, building that capability, deploying that capability, and running that capability and maintaining it in production, basically until that capability is no longer needed. And these teams, I'm not sure if you're familiar with this idea of two pizza teams that was popularized by Amazon, or this idea that if a team can't be fed with only two pizzas, then the team is too big. And that's sort of the size that we're talking about. So how do you actually decide what the partitions are? So in many cases, there are a lot of tools that you can use. A simple tool that folks will use is this idea of nouns and verbs. So looking for the nouns, and those become my service boundaries. Looking for verbs, those become my service boundaries. But ultimately, this is a fairly simplistic tool and has somewhat limited utility. Another thing that you can look at is the single responsibility principle, or this idea that a component in the architecture should do only one thing. It should have only one responsibility. And in many cases, this is defined as it should have only one reason to change. And this can work for us if we don't get too bogged down in agreeing on, well, what exactly is a reason to change. So a tool that I'm seeing used very successfully to do these partitions is this idea of a bounded context from domain-driven design, or this idea that essentially there is no one domain model that can actually describe all of the data that your business wants to think about. Because ultimately, you're going to have cross-cutting concepts in that domain that have slightly different semantics in different contexts. So what we're looking at here is a domain model for a movie distribution business. And so on the left-hand side, we have this product catalog service. And the product catalog service thinks about movies, but when it thinks about movies, it's thinking about the actual motion picture itself, you know, that has a title, that has actors and actresses, directors, a genre associated with it. The system on the right is an inventory system. And the inventory system also thinks of movies, but it thinks of them in the context of kind of gluing a name to a piece of media, DVD, that we have a certain number of, and we have those numbers in different locations. So I know where these movies are and how many of them I have, and how many are in circulation and so on. So I could attempt to model both of these in a single system and mash all of the, and there'll be many other concepts within a system like this that need to represent movies. And I can mash them all together into a single domain model. And movie is going to become this very large concept that sometimes we'll call it like a God object, for example. And anytime we need to change the system, we're likely going to need to go through movie. So instead, what we're doing here is we're drawing these bounded contexts around product catalog and inventory. And we're basically saying, let movie mean what movie means to the product catalog, and let movie mean what movie means to the inventory system, and then create lightweight integration points between them such that I can map a movie in one context onto a movie in another context, but then not force each of these contexts to consider the other context definitions of that term. So when we do this, we can start to think of our services and the data that these services govern as bounded contexts. And when we do that, we create this API boundary that doesn't just protect the code, but it also protects the data, and not just the data, but the representation and the storage technology associated with that data. So we can start to adopt this idea of polyglot persistence, or using the data store that's most appropriate to the job that we're trying to do. So how do we actually integrate these services now? And this is the point where I like to explain that this is not so much a new architecture. It's just a reframing of a very old architecture. And we find its origins, in a sense, in this idea of Unix and pipes and filters. So when we look at Unix, Unix is primarily structured, that environment is structured as a set of very focused, very small programs that do one thing and do one thing well. And the way we create integrations that use multiple programs is by linking them together through these pipes and redirects. And the integration mechanism is actually quite dumb in that these pipes, they don't know anything about the data that is traveling through them. All they're doing is linking the output stream of one process to the input stream of another process. And all the smarts that allow me to actually deal with the data flowing through that mechanism actually ends up in the endpoints. And this is very different from how we've traditionally implemented service-based architectures using things like ESBs. So in an ESB, we tend to put all the smarts in the communication mechanism. And the services tend to not have a lot of knowledge of the world around them. Whereas in this style of an architecture, it's actually the inverse of that. We put the smarts in the endpoints, and the integration mechanism does not have a lot of knowledge about the services that it's actually joining together. And a colleague of mine, Neil Ford, describes this as choreography over orchestration. So orchestration is this idea of central control, where we have a large heavyweight bus that is representing all of the policy, all the integration and routing logic, and it actually is governing the architecture. And anytime we need to make a change to the overall system, we end up very often touching this enterprise service bus, which if you open up, looks again like a boiling pot of spaghetti, and it hides a lot of the complexities in the architecture. Whereas with microservices, we're actually exposing the complexity in the architecture and placing the smarts in the endpoint, allowing them to choreograph their interaction. So it's very much like the comparison of the orchestra to the ballet. So when you go to the orchestra, you have a director standing in front of the musicians that's telling them what to do. And he takes the place of the ESB in the services-based architecture, whereas when we look at the ballet, there is no central control during a performance, and the actual dancers have to adapt and in some cases change their behavior in order to have a successful performance. And that's what we find in these microservices-based architectures, where the services themselves are actually responsible for their integration with the surrounding ecosystem, which is a nice segue into this idea that none of this is a free lunch. So Ben Wooten, several months ago, published a really great article at High Scalability titled Microservices Not a Free Lunch. And in that article, he itemizes a whole lot of the difficulties that we run into when we deploy architectures like this. So obviously, we're deploying many more things in an architecture like this. In many cases, if we fully adopt it, we're delivering many more technologies simultaneously. And we've also created a distributed system. And distributed systems carry their own sets of complexity. And this is not free. We have to increase our discipline. In many cases, we have to pay for a much more significant operations overhead. So there's a lot more things that we have to do to keep this infrastructure alive, not the least of which is this idea that it's very difficult to monitor one of these architectures, whereas monitoring a monolith is actually relatively straightforward. And we have to have a very strong cultural relationship between development and operations if these are not already in place. And we have other challenges. So our testing strategies that work with monoliths don't necessarily work very well. And Martin Fowler carries this a little bit further with this idea of, if you think about the carnival ride with the sign that says you must be this tall to ride the ride, he makes this statement that you must be this tall to use microservices, that there's just a few basic disciplines that you're going to have in place to be able to build and deploy and keep alive an architecture like this. So being able to provision new environments very rapidly with the runtime stacks, the middleware stacks, the data services, the message brokers that you need to be able to develop and test and stage and ultimately run in production these systems. And you have to be very good at monitoring not just the apps themselves, but also the emergent interactions in this distributed system. And you have to be able to turn application deployment very, very quickly, because as you're deploying more and smaller bits, if your deployment process is bottlenecking you, you're not going to get the benefits that you want. And then just this idea of a collaborative DevOps culture where we're all working together towards shared goals with, shared incentive strategies to actually get us to be focused not on the goals of our individual silos, but the goals of actually moving that concept to cash relationship forward. So there's a lot of organizational issues here, and with technology, I can't fix organizational issues, but there's a lot of technical issues that we also have to solve. And so one of the main things that we're doing at Pivotal with Cloud Foundry and with Spring is we're building a platform to make it possible to solve a lot of these technical problems of being able to provision, being able to maintain applications and monitor those applications. And so if you look at a lot of the features that you find in Cloud Foundry, like being able to rapidly and consistently provision environments and being able to scale up both on demand and automatically application instances, and being able to maintain the health of those apps, and if they fail, restart them, and be able to handle complex routing and load balancing in a very performant way. Being able to run your Mongo and Cassandra and Hadoop and RabbitMQ and Elasticsearch and all these other services that you want to bring to the table in these architectures. And then being able to get real-time monitoring information about what are the latency characteristics of my services, how are my errors, error rates, what does my request volume look like. But there's also a set of boilerplate patterns that we need to be able to deal with that come out of these these distributed systems. Now, being able to have a distributed versions configuration, being able to do things like service registration and discovery so that we can glue these things together, and being able to integrate these services. And then as we deploy more things, we have more chances for failure. So being able to build fault-tolerant architectures and being able to configure these things through asynchronous messaging and have configuration changes trickle through an entire architecture in a very standard way. So this is what Spring Cloud is actually bringing to the table in an umbrella set of projects to help us realize those boilerplate patterns. And one of the ways that it's doing that is by starting to wrap a lot of the boilerplate solutions to these problems that have been open sourced by Netflix. So Netflix has been one of the sort of poster children for this microservices architecture. And in doing that, they solved a lot of these problems themselves in very compelling ways. And what we're doing with Spring Cloud is making these solutions very, very palatable to consume for a Spring developer. So very quickly, as I sort of shut down, I want to just show a very brief demo of a 3 microservice architecture that's in action. It's running on Cloud Foundry and is using the service discovery and the fault tolerance and the routing capabilities that are inherent in Spring Cloud. So if I go over to the browser here, you'll see Pivotal Web Services, which is our public service that we run of Cloud Foundry that you can sign up for and get a free trial to try out. And I have all of the applications and as well as my Eureka and my Hystrix dashboard service and my configuration service deployed as apps on Cloud Foundry. I also have RabbitMQ and MongoDB provisioned as services that I can use in this infrastructure. So if we look again at the architecture, which is actually embedded in the app, we see that we have a customer service, we have a store service, and then we have a user interface service that's actually, in a sense, linking those things together. So the question is how do these services actually know that each other exists? So that's solved through Eureka, which is a service registry and discovery engine. And basically what you see here is that as all these applications are coming up, they're registering themselves with this Eureka server. So I can see that here's my config server, my customer service, my UI, my store service. Now, how did those get there? Well, if you go and look at my Spring application, my config server, I actually deployed my config server as a Spring Boot application simply by annotating it with enable config server. But then to make it register with Eureka, I simply annotated it one more time with enable Eureka client. My Eureka server itself is deployed by creating a Spring Boot application. Again, notice these are basically one class, very small apps. And I'm enabling Eureka server to get that deployed. So again, when my customer service comes up, I'm again saying enable Eureka client. So in all those cases, these services end up being registered here. So now let's talk a bit about what the service actually does. So if I go look at my customers here, you notice I have one customer in place in San Francisco named James Waters. And if I drill down into his record, I can see his location, but I also see all of the Starbucks stores that are nearby to James. And this information is actually coming to the UI through a hypermedia interface that's created by Spring Data REST. Or I'm sorry, Spring HEOS in this case. So this bit right here is the data that's maintained by the customer service. But all of the store data is maintained by the store service and is represented in the customer service by a hyperlink. So if I took this hyperlink and I drop it into another browser window, you see all the stores coming up. So the question is what would happen if the stores service were to go down? Well, if you go back to the architecture diagram, you see that we're actually coming to the customer service through a load balancer called Ribbon, which is actually also tying into, you don't see it on this architecture, a circuit breaker called Hystrix. And basically what that's doing is protecting my dependency from cascading failures. So I have a monitor that actually tells me, what is the health of the link between the customer service and the store service. And I can find that in this store integration class. I have a method here that's creating that hyperlink called get stores by location. And the way I turn that circuit breaker on is simply by annotating it with Hystrix command and providing a fallback method. So when this circuit is tripped to open, meaning that I've detected that my dependency is unhealthy, instead I'll get this fallback behavior, which is to return null. And that's going to have the effect of turning that store list off. So let's just test that out. I'll go to the command line and I'll kick off a shell script that's going to really bang on my customer service significantly. And if I go back here, you see that the number of requests is actually increasing fairly rapidly. The circuit's closed and all of these requests are healthy. So I'm now going to induce a failure in the architecture by telling Cloud Foundry to stop the store service. So Cloud Foundry has now stopped the store service. If you notice in the top pane, the hyperlink representing stores went away because we're returning null from that method. And that also has the effect of in the user interface, if I again go back to customers, we see that there are no stores anymore for James. If I look at my Hystrix monitor, I see that my circuit has been tripped to open and I'm intercepting all these requests now and responding with default behaviors. Occasionally, I will actually poll the dependent service to see if it's healthy again. So you'll see the number of errors go up to 1, 2, or 3, but then we'll flip back into a state where we're responding with null. So if I want to resuscitate now the store service, I can do that. And as the store service is starting back up, we can go back over to the Hystrix dashboard and we can continue to watch that. And in just a moment, we're going to see it trip back to closed. So the circuit is now closed again, and we're seeing successful requests to the store service. If you look at the terminal, you see that the store's hyperlink is back in place. And then if we go back to the UI, we see that we have also recovered our functionality. It's no longer turned off. Okay, so that was a quick demo of the Spring Cloud stuff. So I want to finish up with just about 3 more slides before we go to questions. And just this idea that this architecture microservices, well, it's not entirely new. This style of delivering services is relatively different from what we've seen in the past few years. And it's really the first architectural style that has shown up post the continuous delivery conversation, post the DevOps conversation. So you take a bunch of teams that are thinking about the ideals of how do we do continuous delivery and how do we do DevOps, and you see the architectural styles that they're developing. And in many, many, many cases, what's popping out is what we're now calling microservices. And one of the reasons for this is that we have a very operational focus. We've had service-based discussions for a long time, but in many cases, they have only been effective on the whiteboard. And again, my colleague Neil, he makes the statement that architecture is abstract until it's been operationalized. It was very easy for us to draw the ESB on the whiteboard, and it looked very good. But when we actually went out and tried to deploy and operate this and then do things like continuous delivery with it, ultimately, because it was not well operationalized, those architectures fell over. So my corollary to that statement is that architectures that are not operationalized, they really effectively exist only on whiteboards. What we get in practice is actually something that is far less effective. And so ultimately what we're trying to do by combining microservices with Pivotal Cloud Foundry, with Spring Cloud, what we're trying to create for ourselves is this idea of an operationalized architecture so that we can effectively do DevOps, so that we can effectively do continuous delivery, and ultimately so that we can, again, speed up that innovation cycle and be able to shorten concept to cash and deliver value to our customers a lot more quickly. So that's the end of the prepared presentation. So I think we can take whatever little bit of time we have left and drop into Q&A.
Awesome. Thanks, Matt. Can you hear me?
I can hear you great, Peter.
Okay, fabulous. So we don't have any questions at the moment, but one of the ones that I've heard being at Spring One, and one of the ones I hear, out with you and out with other people talking about this stuff is, actually, we do have one question coming in, but let me park that for 1 second. What are some of the, and maybe don't, spend too much time on it, Matt, but microservices are kind of a darling architecture right now. A lot of people talking about it. Not always a lot of people talking about the pitfalls, and they talk about the goodness, but, what are some of the challenges that you're going to run into trying to adopt this architecture and this organization structure, to your earlier point? And how does a PaaS, is a PaaS needed to solve those things, or like in what, what's the relationship there?
Yeah, so ultimately what it boils down to is one of the primary challenges, if you're not good at stamping out environments already, and because the real thing here is we're wanting to go fast. It's hard enough to go fast with one thing. It's a lot harder to go fast with 10 things, and it's even more difficult to go fast with 100 things. And so ultimately, in order to be able to do that well and then be able to handle, all of these distributed systems concerns that show up and things like eventual consistency and things like fault tolerance, you just, you have to deal with a lot of concerns that you didn't have before. And whether you adopt a off-the-shelf PaaS platform or not to help you solve those problems, you're going to have a platform. And so if you look at what Netflix did, they decided, we're going to, make supporting an Amazon Web Services centric architecture a core competency for us. And we're going to, really, seek out building a talent base within the company of tens or hundreds of people that are focused on making that work well. And what did they do? They went and they built a platform. So if you can do that, and if that's one of your goals, great. Most companies are never actually going to go do that. Most companies are going to say, okay, I can't adopt this architecture, it's too hard. Or they're going to say, I've got to go get something that like what Netflix built, but somebody's going to have to build it for me. And so that's where a platform like Cloud Foundry comes into play, because I can take that and I can run it, and I can have companies like, Pivotal help me, run that and understand how to get that up and running so that I can go focus on building apps and let Cloud Foundry, focus on, getting those environments built out and letting Spring Cloud help me deal with all those distributed system concerns.
And that's not something that Amazon really handles. That was something that Netflix had to build, to your point. Yeah, totally.
Right, exactly.
Thanks for that. Yeah, absolutely. Okay, cool. Praveen Kumar asks, how will filtering be done in this architecture? Usually you have big SQL with all the filters and where clause, but since you can't join the data between the microservices at the database layer, you kind of have to do this in the application, he thinks. Is there, if that's true, is there a performance impact? I think this is a great question, one I think I've heard a lot. That was the other sort of one I was going to mention, so way to Praveen for asking it. But, as you were saying earlier, the different microservices kind of own their own data, right? How do you, eventual consistency? Like, how is that dealt with, and what's the performance impact to Praveen's question?
Yeah, this is a huge issue that you have to deal with, and ultimately, again, it boils down to that concept that every time you get something, you have to pay something, and so you're what you're doing is you're taking a lot of capability that we kind of mash down and let the database layer take care of for us, and we're saying, okay, well, we're going to manage that elsewhere because now we have all these different data services that have things in front of them, and it's like, okay, I want to ask a question, or I want to deliver a screen that's going to touch a bunch of these different things. And so if you do that kind of naively and say, okay, well, I've got my little mobile app and I'm going to call the first service and get some data, and then I'm going to call the second service and get some data, and then somehow munge all that into what I want to display to my user, you're going to die a very painful death of frustration in trying to make that work. So that API gateway pattern that I talked about on the earlier slide, and I can actually throw that back on the screen very quickly, is actually playing a lot of that role. So what that API gateway's job is doing is for one of these apps. So this is not an ESB. This is not a monolithic thing. What you usually see, and especially how Netflix use this, is that each of their different device endpoints, whether it was an iPhone or an Xbox or a set-top box, whatever it is, it needs to consume these back-end services. And so they would build one of these gateways whose job is to sort of act like, my own little API for that device. And what that API looks like are the types of queries that I would have made, in many cases, that monolithic system. And so the key is what's in the guts of that API gateway. And so much like, you would have a database deciding how to most efficiently join all of these tables together, this API gateway that you're writing is now deciding how to efficiently join the results of all these microservices calls. So it's super important to be able to do that in parallel concurrently very well. And so this is where you start to see a lot of the adoption of these reactive patterns that we're starting to enable more and more with things like Reactor and new additions to Spring integration and other things that you can build. And also you're going to see other toolkits for this, come out of the Cloud Foundry space for helping to build these gateways. And so its job is essentially to kind of do the joins and the transformation and aggregation of content and make it look like to these clients that we're still kind of doing things the old way, but we're getting the benefits of decoupling everything on the backside. Does that make sense?
Yep. Nice. I like that. Thank you. And just a quick side note, I thought what was really cool about that demo was the way it failed gracefully, right? When when you killed the store service, that you didn't get some like nasty 500 error or blank freaking screen. It was just that piece of it didn't work, and I just thought that was really cool. Next question from Jeff James. He asks, how can you validate upfront the whole microservice architecture, in particular the granularity of the services? Now, Matt, I know you talked about this earlier with the single responsibility principle and the nouns and the verbs and some of the other things, but maybe just a teeny bit more on that, because we're actually getting a few more questions, so I don't want to spend too much time on it since we already did cover it a little bit.
So how do you validate that you're basically doing the decomposition correctly?
He phrases it the granularity of the services, which I take to mean, the decomposition. It's very challenging, and it's hard to give a quick and fast answer. But one thing I can tell you is what not to do, which is don't start seeking, numbers of lines of code or numbers of, verbs or service calls or things in the service, because ultimately what you're going to end up doing is creating artificial decomposition, and you're going to be creating service granularity that's probably more extensive than what you want. But you're going to see articles out there and say, oh, yeah, a microservice should only be 150 lines of code or less. And that's just as fallacious as when we would say that, a Java method should be only, 30 lines. And if it's 31 lines, it's too long. So heuristics like that are actually quite ineffective. Really what it boils down to is, thinking about what is the minimum size of a capability that's actually going to deliver real business value to the architecture. And for some capabilities, that's going to be 150 lines of code. For some capabilities, that might be a couple of thousand lines of code. You have to really focus on, what is the thing doing and what is its job in the architecture. And ultimately, if I need to do something very differently tomorrow, is this thing going to keep getting hit? And if it is, I probably need to decompose it. So it's really focused on change and what are you trying to accomplish? Yeah. It's hard, and this is a hard one to answer. I agree. And I totally agree with you. Lines of code are the wrong way to look at it, because it's like, that's so, you put in a good framework like Spring Boot, and what does that really mean?
Exactly.
Suddenly, and then, so that's highly framework dependent, it's highly tool dependent. And then, you watch that Adrian Cockcroft interview on InfoQ, I think it was like 30 minutes long. It's one of Humble's videos with him. And, when he was talking about this, he made it very clear that this is sort of the art in the science, and this is where, that this is not a, there isn't like a prescriptive way to go about this. It's a really tough one to answer. And thanks for taking a stab at it. I appreciate it. The next question comes, I'm going to skip Praveen again, just because he already had one question that he asked, and just make sure I catch the others. Taniel Plud asks, how does a microservice architecture perform in near real-time applications? I think this is interesting because you were just mentioning Reactor.
Yeah. How do we perform in near real-time applications? I'm not really 100% sure what we're talking about here. Because to me, when I think of my primary goal when I'm building something like this is I'm thinking of the person that is, holding a phone and trying to get a response to some question. Very, what do we tolerate when we're dealing with our phones? If response time is anywhere, greater than a second, many times we start to get frustrated, right? So I think, again, it really boils down to how you're building your edge services is going to govern your performance. So
Matt, what I suspect, what I smell behind his question here is not necessarily what's the the Google 250 millisecond or whatever, 350 millisecond or whatever it was, barrier to glass for the end user device, but more either machine to machine communication or more like Internet of Things, high volume. That's kind of what I'm smelling. He wasn't specific, but Taniel, if you're still on the line and you want to clarify, please feel free. But that was what I was smelling a little bit. I could be wrong, but.
Well, yeah, and that's a huge concern too, because if you think about service to service communication, you have to start to think about network and network distance and number of hops. And, it's just another proof point that, having a very strong operational discipline that is working in dovetail with your team that's actually developing the apps and services, so that we understand that, we're not making bad or poor decisions about how we're laying things out. And then ultimately, having a platform, like a Cloud Foundry that's going to make a lot of those decisions for me and control a lot of that traffic routing for me so that I have the good decisions sort of made on my behalf. But then there's another kind of more subtle point that is, related to how we actually decide to make service calls. So, obviously a network call is more expensive than a method call. So if all I did was take the method calls I was making to the service that's, running in process with me, I divide those up and I turn all those method calls into network calls, it's going to fall over pretty quickly. So there's this kind of spectrum between, coarse and fine-grained communication. And we kind of went down that path when we did EJBs, like 15, 20 years ago, we want to start to make very coarse-grained calls. And because we were doing all these remote, we thought we were going to have all these remote beams floating around and we're going to be communicating between them. And we're doing, at a very high level of abstraction, we're doing the same type of stuff. So, this idea of we're going to take a bunch of methods and generate a REST interface, not a REST interface, but generate some web services interface from it, and it's just going to work, is actually going to turn into a high degree of frustration. So you really need to think about, how much work can I get done in a call, and that's going to drive a lot of that performance characteristic.
And I think asynchrony can help there a little bit.
Absolutely.
Stuff like Reactor, and I think there's other third-party things out there like RX Java and and Scala and stuff like that. But yeah, that I think there is a good natural fit between asynchronous processing and and microservices. I think those are a very nice fit actually for a number of reasons. But okay, cool. Sorry, I don't mean to kind of gloss over it. It's just that we're getting a whole bunch more questions now all of a sudden, and
sure.
We're already 15 minutes after the hour. Matt, one idea just to handle some of the flow here might be that we take the questions and maybe you kind of you and I work on them after the webinar and post some of the answers to your blog or something like that, just because a bunch of them are coming in. But anyway, let me move on to the next one. Let's see. So we talked about near real time. Oh, yeah. Henry Wang asks, any guidelines or suggestions to transform a monolithic app into microservices? The $1 million question. Way to go, Harry.
Oh, sure. Yeah, that's something that I talk about almost every time I get into a whiteboard discussion with, one of the customers that we're working with. Yeah. So I'll do it as quickly as I can. The first thing you do, in my mind, is you draw a line in the sand and say, okay, everything that we do that's net new, that we would have normally gone in and attached a new function to this monolith, we're going to create a microservice representation of that. And in order to do that, we're going to have to integrate the two. So one of the things that I see is you build this idea of an anti-corruption layer that protects that microservice from being too tightly bound to the monolith and sort of brokers the communication between the two. And that can be just another service API. And in a lot of cases, you can use sort of the gateways and things and Spring integration to great effect to help provide that insulation. So you get good at delivering net new functionality as microservices first. And once you've kind of got that discipline down, then it's time to start saying, okay, how can I start to break this thing up? And so you need another decision guide there, and that is, what are the things that are changing most? Because ultimately, the things that are changing the most are the things that you want to be able to deliver continuously. And so those are the things that are being inhibited the most by being attached to that monolith. So then you start to say, okay, let's find modules that make sense that really need to change, and again, chunk those off into new microservices and build further anti-corruption layers to kind of integrate those two things together. And then as you're consuming those common services that that you chunked off, redirect them to the microservice representation instead of, the monolith representation of that. So you'll do that for a period of time, and you're gonna reach two possible endpoints. One endpoint is you've decomposed the whole thing, and you're done, and you can actually start to remove those anti-corruption layers because you don't need them anymore. Another possible endpoint is you've actually reached the point where you're no longer going to get a huge amount of value from doing further decomposition, because the services that you've left behind are actually, they're not changing very much. They're kind of done, and you just don't really feel the need. So you might leave a certain skeletal portion of that monolith behind that, has an API layer to it, and then everything else is moving forward. Or maybe you find some services that you just don't need anymore and you can simply delete. But that's kind of the process that I walk through with people, and it seems to work well. And there's actually, if you Google around a little bit, and maybe we could even put out some links in some notes later on to some different case studies that people have posted of walking through that exact process with their architecture.
Very cool, Matt. Thanks. I think if we can do one or two more, we still have almost 50 people on the line from 100. So it seems like these are good questions. Maybe we'll just do one or two more, and before we call it a session here, and we'll do this again at 10 a.m. Pacific. By the way, if there are folks that really are hot to get some questions answered and you want to join us again, please feel free to come to this towards the end of the second session. So let's see. Hopefully this is a little bit more of a yes/no question. Praveen Kumar asks again. He says, "Is the service registry discovery that you mentioned in Spring Cloud, is that an implementation of the gateway pattern?"
There's a lot of things called the gateway pattern, so I'm not necessarily sure which one you're referring to, but I wouldn't characterize it as one myself. The service that Eureka that Spring Cloud is sort of wrapping for us is not actually gating any traffic between the instances or services. It's all it's doing is allowing services to announce themselves, and then allowing other services to query and see what services are available. But once I kind of obtain that information, then I'm actually going directly point to point with those things.
Yep. Matt, while we're wrapping up here, would you bring up the Roadshow page on your desktop browser so that folks can look at that? And
no problem.
And I'll speak to that in a minute. So while you're doing that, let me tee up the next question for you, because I know that's probably fairly brainless. Let's see. A lot of good questions here. Thanks, guys. This is awesome. What are some consequences of the data model translations between bounded contexts? Asks JC.
Well, I think there's two huge consequences out of the gate. The first consequence that could be a whole other presentation in itself is, how do you start to think about transactional behaviors across all of these data services? Because in some cases, you're going to have to start to, if you really want to go that way, you're going to be thinking about distributed transactions, and that's a whole huge rabbit hole itself. And in some cases, that's not even going to be possible, and you're really going to have to start to get comfortable with, architectures around eventual consistency, and what are the implications there. And there are patterns and things like event sourcing and command query responsibility segregation lots of patterns that if you need that complexity, you can start to go down that road to help you deal with some of those things. But you're ultimately going to confront some level of that. And then another one of the consequences that you're going to run into right out of the gate is, okay, I want to ask questions like from a reporting mindset. Like I want to discover something about what's been the overall behavior that normally I would have asked. I would have written some arbitrary SQL query to my database, and all the data would have been there, and it would have joined and given me back the answer to that question. Now I can't do that. So am I making API calls to all these services? Hopefully not. So this is where there's some patterns for creating sort of sidecar reporting database structures to get this done. And I talked about this a little bit at Spring 1 of this idea of as things are happening in your services, of venting out those things to a message bus so that you can feed them into something like, for example, a Lambda architecture, which again I don't have time to go into, but you can query for Lambda architecture, and you'll see all sorts of resources. But this idea of basically putting everything that's ever happened into some long-term archive store, like for example HDFS, and then being able to write things like MapReduce jobs to answer those questions in a batch form, but also kind of having a streaming layer, something that I might use a Spring XD for to do some real-time analytics on that data as it's changing. So, basically you still have to do at a high level all the things you always wanted to do, but because you've changed your architecture, the solutions to those problems look very different. In some cases, just substantially different. But because we know we still have to do them, we're solving the problem. So as you decompose the data, those are a couple of the main things you're going to run into. Not the only things. That we could go on a whole discussion for probably another hour or two. There.
Totally. And it's funny, actually, one of the other attendees, Jeff James, had asked specifically, do you consider, command query, CQRS, and event sourcing as valid options? So that you kind of, I'm really happy you touched on that. Thanks. And if you need that complexity, absolutely, sounds like a good fit for microservice architecture, but, anyway, so I think we're pretty much going to have to wrap. It's almost 30 minutes after the webinar was supposed to be over, which is awesome. So deeply appreciate all your questions. This is great, and these are not these are really great questions. So thanks. It's clear that you all are really engaged in this and really actively thinking about it. I think that's awesome. We'd love to help you more. If you go to the web page that Matt's got up there on the browser, or just Google for Pivotal Cloud Platform Roadshow. We're doing a United States-based tour. It's not just United States. It is international. I think it's Munich, and there's a few others. But thank you. Perfect. Yeah, I appreciate that, Matt. Yep. So you can see some of the upcoming cities, and the event really does kind of focus and talk quite a bit about microservice architecture, how that relates to platform as a service, how that relates to some of the Spring Cloud technologies and DevOps and, et cetera, et cetera, et cetera. A lot of the things Matt's touched on today. So I highly encourage you to tell your friends about these events, tell your coworkers about these events, and register for them if they're in a city that's convenient to you.
Free.
And we're going to continue to be running these. I think the word from management is that we are going to continue to be running these things. So even if you miss this time around, I think we're going to be doing this roadshow again. So keep an eye on this page and keep looking for more events. And obviously, if you want to subscribe to at Cloud Foundry on Twitter or at Spring Central on Twitter, you'll hear about these from us as well. But okay, great. So I'm just going to wrap up a little bit and just mention to everybody, we are recording this talk, and it's going to be posted on spring.io/video sometime in the next 2 weeks. If you want to get a notification of the webinar replay being available so you can share it with your coworkers and such, just subscribe to the Atom feed at Spring.io blog, and you'll also get all the great blog content from our engineering teams. Or you can, if you just want the videos, for some reason, or, you can subscribe to the YouTube channel, which Spring.io video redirects you to. Also, on November 4th, on October 23rd, I apologize, later this week, just this Thursday, Josh Long is coming back with the Vaadin team, which is a GWT-based UI framework, and they're going to be talking about building beautiful UIs with Spring Boot and Vaadin. Again, this is a free event. You can register for that. If you go to our blog or go to any of the latest This Week in Spring entries from Josh, you'll find links to the registration page. And to continue our microservice webinar series, on Tuesday, November 4th, the good Dr. Dave Sire will be coming to talk to us about security for microservices with Spring and OAuth 2. Didn't see any security questions from you guys today, but certainly something that you're going to want to look at as you get out of sort of exploration phase and into testing and eventually production. So that's on Tuesday, November 4th. And yeah, I think lastly, if you're interested in Spring Cloud, just realize that we have not enabled direct HTTP downloads on our site for the Spring binaries. So typically we want people to get them from Maven and Gradle because it's just a much better experience. If you're really desperate and you need an HTTP download, you can get them from our Artifactory server on repo.spring.io. Again, that's repo.spring.io. And then if you Google for the Spring repository FAQ, it'll show you how to deal with that. Great. And most importantly, please, we're going full bore on Spring Cloud and microservices, and obviously Cloud Foundry is the Cloud Foundry team is definitely on fire. So give us your feedback on Twitter at Cloud Foundry and at Spring Central. And just thank you so much for all the great questions and joining us today. I think we pretty much got everyone's questions. So look forward to seeing you on a webinar again real soon. We'll be doing this again at 10 a.m. If you want to try to. If you didn't get your question answered and you want to sneak back in, I'll remember your name. Matt, anything you want to say to wrap up?
I think you covered it pretty well. I'm just excited to have this many people hanging around for this long to talk architecture questions. So thanks, guys, for hanging out with me, and I really hope it was super valuable to you.
Cool, Matt. It was great. I definitely learned something listening to this too, and I spend a lot of time on this stuff. So thank you. All right, folks. See you again soon. Take care.